Today we're going to talk about section 3.3, and section 3.3 is the properties of logarithms. So we'll go ahead and get started. Now, objectives 1 through 3 talk about using the product, quotient, and power rules. If you take a look at the way these rules work, the first thing is if you're going to take the logarithm of a product, you can split it into two separate logarithms, but notice how instead of multiplying, we're going to do the sum. In terms of the quotient rule, if we're going to take the logarithm of a quotient, meaning a fraction, it's the same idea as before. We can turn it into two separate logs, only this time we're going to subtract in between. The last one is the change of base, the power rule. And the idea here is that the exponent, if you're taking the logarithm of something to an exponent, we get to swing that exponent down into the front, as you can see. In the next slide, we'll see how we can actually start using these rules. So for this example, we're going to use those rules we just learned to expand the following logarithms. Now remember, the word expand means to make it longer, to write it longer. So we're going to take something short and write it longer. In this first example, you can see that we have the log of 10 times x. So we have the log of a product. Remember, if you think about what we just learned, that means that I can switch it into the log of a sum. Now the base is going to stay the same. So we're going to switch this into log of 10, and it's log base 10 of 10 plus log of x. So because it was a product, I'm going to switch it to a sum. Now we can simplify it a little bit further because we know that the log base 10 of 10, we know that simplifies to be 1. So we get 1 plus the log of x. Those two things mean the same thing. This one now is just an expanded form. Let's take a look at the next one. The ln of e cubed divided by 7. So now we have the log of a quotient. Same idea as before, only now instead of a plus, we're going to switch it to a minus in between. So we're going to have an ln of e to the third minus the ln of 7. Now our rules from the previous video tell us that the ln of e to the third, remember that the ln of e is just 1, and so that means that turns into 3 specifically. So we can rewrite this as 3 minus the ln of 7. Let's take a look at the next one. The log base 7 of 5 to the 4th power. Now in this case, we're just going to go ahead and use that power rule that tells us we can take the exponent of 4 and bring it into the front. So this is going to turn into 4 times the log base 7 of 5. Now the log base 7 of 5 doesn't simplify very easily, so we'll just leave it at that. And finally, the last one, the ln of the cubed root of x. Now one thing to remember, if I just rewrite the cubed root for a second, the cubed root is the same thing as x to the 1/3 power. So now we'll use that power rule and bring that 1/3 down in front. So we get 1/3 times the ln of x. Let's go ahead and look at some more complicated examples that'll require us to put more than one of these together at a time. Alright, so once again we're going to expand these logarithms as much as possible. Taking a look at the first one, the first thing I notice is that I have the log base b of a product, x squared times the square root of y. So we know that the first step would be to switch these into a sum. Log base b of x squared plus log base b of the square root of y. Now the next step, taking a look, I see I have two exponents. I have a 2 I can bring in front, and remember the square root, that's a 1/2 exponent. I can bring that in front as well. So if I do that, I get 2 times the log base b of x plus 1/2 times the log base b of y. There's no more exponents, there's no more multiplying or dividing, so that looks like it's as far as we're going to go in this case. We don't know what the base is, it's base b, so we can't do any other simplifying. Let's take a look at the other example here. So we have the log base 6 of the cubed root of x over 36y to the 4th. Now hopefully the first thing you're noticing is the division there, so you're thinking we should switch this into a subtraction problem. Log base 6 of the cubed root of x minus log base 6 of 36y to the 4th. I also see right away in the beginning here the cubed root of x, a power rule, so we can bring that down. Remember, the cubed root is the 1/3 exponent. And then I also see a product here in the second piece. Now I'm going to put a parentheses, and I'm going to split this into a product rule. Log base 6 of 36 plus log base 6 of y to the 4th. Now notice that I did put a minus with a parentheses, and the reason is I want to make sure I subtract both of those. Now looking at the next step, I'm going to leave my 1/3 log base 6 of x. Nothing really is going to change there. Now log base 6 of 36, this is like saying, I'm going to do this over on the side here, log base 6 of 36. 6 to the what equals 36. And in this case, 6 squared is 36. So we're going to just switch that to a minus 2. And then I'm also going to put another minus sign. What I'm doing right now is distributing that negative. And I see one more product rule, so we can take the 4 and bring it down into the front. 4 times log base 6 of y. And it looks like now we're simplified as far as we go. We have no more product, power, or quotient rules, and we don't have any other logarithms that we can actually figure out. Now that we've seen how to expand logarithms to write them the long way, we're going to go ahead and look going the other way now. If they're written long, can we condense them into being short? So now the next step will be to condense these logarithms. We're going to use our rule backwards. In this first one, I see a sum, so hopefully you're thinking product rule. I see that my logarithms have the same base. That's key. If they didn't have the same base, we could not use the product rule. Let's go ahead now and use our product rule. So we're going to say log base 4 of 2 times 32. Now 2 times 32 is 64. And remember, log base 4 of 64 means 4 to what power equals 64. And hopefully you know that 4 to the 3rd equals 64. So you can see that by using the product rule, we were actually able to find the final answer for these two logarithms. Had I tried that in the beginning, 4 to the what equals 2, not as easy to decide, or 4 to the what equals 32, but still possible. Okay, so you can see you could figure these out this way, but instead, by using the product rule, it makes us go a lot faster. Let's take a look at the other example over here. Again, we're going to be condensing. We're going to try to write this smaller this time. So, for the first one, in the beginning, I see, right away I see a subtraction of two different logarithms. Notice these logarithms have the same base. They're base 10. So we can combine them into one log. And we'll take the first thing divided by the second thing. Now, 4x minus 3 over x, that doesn't simplify any more than that. So it looks like in this case, this is as far as this one goes. Let's look at some more examples. Now, in this example, in front of our log, our first log, we have a number being multiplied. Notice in both of these we have that. So the first step here would be to do the power rule backwards. So we're going to swing those up as exponents. So we're going to have the log of x to the 1/2, so that's the square root of x, plus the log of x minus 1 to the 4th power. Now I have two logarithms being added, so we can change this into a product. So we've got the log of the square root of x times x minus 1 to the 4th power. And that will be our final answer. Let's take a look at the other example here on this slide. Now, first thing to be careful about, notice all these logs have the same base, base b. So we can go ahead and use our rules. Now, the first thing we'd want to do is take all of these exponents and swing them up to the top. So we've got log base b of x to the 4th minus log base b of 6 squared minus log base b of the square root of y. Now, I see that we have two minus signs in a row here. So what I'm going to do right now is I'm going to go ahead and factor out that negative sign. Remember in the expanding process, we distributed the negative, so this time we're going to factor it. We're going to pull it out in front. So that's going to turn this into log base b, and we'll just change this to a 36, 6 squared, plus log base b of the square root of y. Now by doing that, you can see that we're going to get a product rule inside the parentheses there. So let's rewrite that with the product rule. We'll have log base b of x to the 4th minus, and then we'll get log base b of 36 times the square root of y. So if we want to finish this off, we could go ahead and finish it off now. We've got a minus sign in between two logarithms. So now in this case, we're going to have a quotient rule. Log base b of x to the 4th divided by the 36 square root of y. And so we've combined it into one logarithm. Before we take a look at our last objective, I want you to go ahead and answer this multiple choice question. This will go in your Google form. Notice in this case, you're going to use your properties to expand the following expression. So here's your expression, log base 9 of 81 over x, and I want you to expand that and match it with one of them listed. Now we'll go on to our last objective. Our last objective is to use the change of base property. Now the nice thing about the change of base property is it's going to help us evaluate logarithms with any base using our calculator. Remember, at this point our calculator only works in base 10. So we'll go through the example, and I want to evaluate log base 5 of 140. Now I really want to know what does this equal, so we'll say equals x. This is something we've done before. We could use the log loop and say 5 to the what equals 140. Now the problem here is that nothing really works nicely there. If we put this in our calculator, it isn't a nice answer. So the idea we're going to do right now is we're going to go ahead and, just like we would add something to both sides of an equation or multiply both sides of an equation, we're going to log both sides of this equation, and we're going to log base 10 it specifically. Now the reason I'm going to choose log base 10 is so that I can use my calculator to help me. Now, the nice thing about logging both sides is I have the log base 5 of 5 to the x, and the power rule tells me I can take this x and pull it down in front, which means I'd have x times the log of 5 equals the log of 140. Now remember, the goal is to solve for x to get the x alone. So all I have to do right now is divide both sides by the log of 5. And that tells me if I grab my calculator, those will cancel out, and I punch in the log of 140 divided by the log of 5, that would be what the answer is to the log base 5 of 140. Now, some of you may remember the shortcut from Algebra 2. And the shortcut from Algebra 2 basically tells us that the log base b of m is going to be the same, if you see above, as the log of m divided by the log of b. And we'll use base 10 so we can use our calculators. Now, you could do the same exact thing, only you'd use the ln instead. So you could ln both sides. Remember, that's just log base e. Either way will work, and that's the shortcut to remember. You could go the long route where you rewrite it as an exponential and then log both sides and divide, or you could use this shortcut I just showed you. So finally, I want you to go ahead and try this last question. It's your free response question. So go ahead and see what the log base 7 of 2,506 equals and put that into your Google form. This is where we'll end today.